Let's talk about flow. What is flow?
Flow is the amount of substance that passes through a certain point over a certain measurement of time.
Okay.
Mils a minute, for example.
Okay. And what kind of flows do you know about?
There are two types of flows. Flow can be laminar or turbulent. A laminar flow is where it is like so. Very bad diagram.
Okay.
Could you see?
So is flow the same speed at all points within that tube then in laminar flow, or does it tend to be faster in certain places?
So the flow in laminar flow, the flow is fastest in the middle, and as you gradually go closer and closer to the edges of the tube, flow slows down.
Yes, that's exactly right. And can you tell me about the Hagen-Poiseuille equation?
Okay, so um, the Hagen-Poiseuille equation states that flow is delta pressure times pi r to the power 4 over 8 times viscosity times length of tube. And
Okay.
the clinical importance of this is that the radius is to the power of 4, so a small change in radius will really significantly impact your flow. Hence, we put in large bore cannulas in patients when we need to give fluids quickly.
Okay. And what's the problem then with using, quite a wide central line to do large volume fluid resuscitation?
A
They,
problem.
yeah, because they've got sort of 14 gauge lumens. So why can't we just use that instead of putting a big gray in?
So they're longer than your grey cannulas, so which length is in the denominator. So the longer the length, the less flow that you can give.
Yeah, that's exactly right. And so we've talked about laminar flow then. What about turbulent flow? How is that sort of characterized?
So turbulent flow is where flow is in currents and it's not uniform and goes all over the place. It's unpredictable. Therefore, there is no equation. However, we can use the Reynolds number, which is a dimensionless number, whereby we can look at the chances of flow being turbulent. So it is velocity times density times diameter over viscosity. Reynolds number less than 2000 is laminar and above 4000 is turbulent.
What about in between 2000 and 4000?
I think it is indeterminate. You can leave it in there.
Okay. Yeah, well, it can be either.
It can be.
Yeah.
It depends.
Yeah, so it's not altogether clear most of the time. When do we care about turbulent and laminar flow clinically? When is it useful to us?
So for example, when we measure blood pressure, non-invasive blood pressure measurement, we occlude the brachial artery, and by releasing the pressure, when we listen to it, we get a sound. It's because the flow that comes into the blood, into the vessel is turbulent, and that's the sound that we pick up. And then the sound disappears again when the blood flow returns to being laminar. Or in breathing systems, when you have angle pieces, you change the direction of the flow, which can make the flow turbulent.
Okay,
Yeah.
that's fine. We'll move on. What is the Bernoulli principle?
This is a principle that states when you get flow through a tube with a constriction, the flow stays the same, the velocity changes, and therefore to make sure the flow stays the same, you get a drop in pressure.
Mm-hmm. And how is this used clinically?
It's used clinically when we have venturies. So by passing a certain concentration of oxygen through a constricted orifice in a venturi mask, you get a drop in pressure, which allows us to entrain air in the atmosphere, and we can adjust the ratio of how much oxygen and air we entrain in order to deliver specific amounts of oxygen.
Excellent. And that's time.